Hello everyone, my name is Nilesh and today I'm going to start a new video series on .NET platform. The primary goal of this particular video tutorial series is to learn .NET platform, and we are learning .NET platform to build some really new age enterprise level applications. Now this goal is very ambitious and too vast because .NET has support of so many different languages and different types of applications that we can build using .NET. But for time being, I have defined this a shorter goal, like we will get started with C# programming language, because out of many languages supported, C# is most popular .NET based language. And while learning .NET language, we will also get introduced to the .NET platform, and we get to know many different things like .NET framework, .NET core. We talked about compilation and execution. We will understand the assemblies. We will see so many different .NET APIs. We will understand about CLR and whatnot. So many different things to talk about. Before I dive into this .NET concepts and all that, I just want to give a little idea regarding my .NET background. I started learning .NET in a very early stage, somewhere in year 2003, where the .NET was just started. And at that time, it was like .NET version 1.0, 1.1. I got exposure. And I really found this particular technology is a really promising one. After teaching .NET for 10 to 12 years, I got busy with some other engagements, some other commitments. And due to that, for a while, I stopped teaching and learning .NET. But again, after another 10, 12 years, when I returned back to the .NET technologies, I found that the technology was already very elegant, and then a lot of new features meanwhile were adding to the language. So I just thought of why not to get started with the .NET again and explore all these new features and also share with you all people. So I thought of started this particular series on .NET, and I'm looking forward to teach all these old C# concepts to the latest C# concepts, and then the more advanced, maybe the web applications with you all. Now, if you have ever worked onto the multiple different languages, then looking at C#, you suddenly get a feel that C# language is one of the most elegant, most beautiful, most thoughtfully designed language. It has got almost every feature that you might see into the other languages, and all those features are incorporated in this language in a very beautiful manner, and it is really a bliss. So if you really want to justify all the features that .NET C# language have, then you cannot really keep starting with some absolute basics like what is variables, and then what is data types, and then what is if else. So I just thought of having some prerequisites for these sessions. So in these sessions, I will assume that people know a few things, especially they have the basic programming skills in any language, of course, but the basic programming skills where you are aware of what is variables, what are the data types, what are the if else, what are the programming constructs, loops, switch cases, functions, arrays, at least some basic idea that you should be having from any particular programming language. And then the second thing I'm looking forward is people should also know at least one object-oriented programming language. Now, object-oriented programming languages are many, but particularly if you know maybe C++ or Java kind of language, you can relate to C# really well. As we will go ahead, I'm also planning to talk about the database connectivity with the .NET. And to learn database connectivity with the .NET, you should be knowing the database, at least any one relational database you must be aware of. And then moving ahead, when we will talk about like a web programming in .NET, I'm expecting that you should be knowing about basic web programming, meaning by HTML, JavaScript, CSS. If you know, that is good enough. Of course, for now, my primary focus is to teach you C#, and for learning C# to get started with this .NET world altogether, I believe that you should be knowing any one OOP language and the basic programming skills. Of course, as we will go ahead, I will be talking about each of these concepts as well. I will be talking about class, I'll be talking about object, I'll talk about inheritance, polymorphism, I'll talk about arrays, I will talk about functions. However, I'm not really planning to talk about them as a first-time learner. I'll be focusing them as a kind of quick revision, the concepts in short, and then we will focus more on practical. I just want to make it very clear that this particular tutorial, this particular whole learning series should be considered as a proper hands-on practical learning. So a lot of time you will see me doing a lot of code right from the first session, and whatever programs that we have done, we will execute those programs and then explain concepts side by side. Of course, initially for the first time discussion, the initial few minutes, initial few hours, you will find that I'm talking more of the .NET platform, .NET framework related concept. But once that initial theory is over, then we can start focusing onto the core C# practicals. And yes, one question that people do ask me many times, that if really I want to get started learning any new technology, or if specifically that .NET or C# programming language, from where I will get some good books or some other good reference, I would say that if you are on the Microsoft technologies, the most beautiful thing about Microsoft technologies is their documentation. After learning and teaching probably more than 2 decades, now I can authentically tell you that the Microsoft documentations are so far the cleanest, best, ready to use documentations I have seen so far. And if someone is insisting to look and read from the books, then I personally recommend that you should be referring online MSDN, Microsoft Developers Network. And out of MSDN, specifically look for a section C# programming guide. This is a book in itself. If you could learn C# from this, you will get the latest features of C#, and that is the most authentic source on Microsoft C# language, right? So this is for those people who want to revise or who want to learn from the books. Please check out this. Now, as I said that this particular tutorial is more of hands-on tutorial. So you must be looking for what kind of setup I should be having on my machine. The kind of setup that you should be having on your machine is, number one, you need to have a kind of a .NET framework on your machine. And .NET framework you will find kind of built in into the Windows operating system. Typically, if you're like with the Windows 10 or Windows 11, it should be absolutely fine to get started with. Of course, now .NET come up with certain new technology like .NET Core, which also allows you to run the .NET application on the other platforms, but we will discuss about .NET Core sometime later. As far as this video tutorial is concerned, I'm expecting that people are working on the Windows operating system, Windows 10 or Windows 11. And second thing, you need a single software installed on your system, and that is nothing but Visual Studio. Of course, Visual Studio comes with the variety of different versions and flavors. I'm looking for the latest edition, which was published in December 2025. That is Visual Studio 2026 Community Edition. Good thing is that this Community Edition is free for the students. This Community Edition is free for the open source software developers. So you can download this from the Microsoft website and you can install it on your laptop. So where exactly you can download this? Let me quickly show you. This is my Visual Studio Community Edition. You can download from the Microsoft official website, and after downloading, it will ask you which features exactly that you want to install. The primary feature that you should look for is desktop-based development and the web application development using C# language. The C#, VB.NET, these languages are built-in supported into the Visual Studio, right? Now, with this background, and as I said that this session will be more of practical oriented. So before I get into the details of .NET framework and other stuff, I would like to get started with some hands-on, some practical HelloWorld kind of program. So assuming that Visual Studio is installed on your system, let me open a Visual Studio. This Visual Studio 2026 edition, and then I can create a new project. Now you find that the Microsoft Visual Studio is supporting so many different types of projects. They are supported on different platforms, and again many different languages are supported right here. Now I'm just looking for a very simple console-based application for Windows at the moment. So let me select Windows. Let me talk about the C# as a programming language. And then I'm looking for HelloWorld console application. There you see that there are mainly two options given. One is the .NET framework, which is the older version of the .NET platform, you can say, which was there over the years. For today's class, I'll be primarily focusing on the .NET framework only. And this .NET framework, you can use it for creating application only on Windows operating system. As we'll go ahead, we will use .NET Core technology. And this .NET Core technology will allow you to run the C# applications on any platforms like Windows, Linux, Mac, and so on and so forth. So for today, let me just focus on .NET Framework first. And then I can click on Next. I need to give the name of the project. As usual, let us give the name called as a HelloWorld. And there is something called as a solution. We will discuss what exactly it is. Select the .NET Framework version. In fact, .NET Framework 4.8.1 is the last version of .NET Framework. Thereafter, Microsoft started with something called a .NET Core technology. And that is the reason I have chosen the last .NET Framework version 4.8.1. And then let me click on Create. Once I have created this, you will be able to see window like Solution Explorer. And under the Solution Explorer window, so there is a solution under which that HelloWorld project is created. Before I explain you anything about this, let me quickly write one single line of statement over here, like console.writeLine. And in that console.writeLine, let me write the message. Let's say hello world. That's it. Nothing else. How do you build this? You have multiple ways. Either you can go to the build and you can click onto the build solution. This will build the whole solution, or you can build a specific project called as a build HelloWorld. The similar thing, you can do it by right-clicking over here, and again, you may use build over there. That is absolutely okay. And then to run it, so there is a button called as start. You can click on the start, and then my program is executed, and you see the beautiful output, hello world. If you just want to make it shorter, just use Ctrl F5 and this will give you the exactly same output. Well, what exactly we have done over here? Let me tell you the idea behind what exactly the solution is and what exactly the project is, and then what is created behind the scene when we did this. So let us consider that a customer reached to you and come up with some problem statement or kind of a software requirement. If the customer is looking for some really big system and is expecting some really good solution from you, then many of the enterprise level problems, they cannot be solved just by writing one console application or making some website. So many times to solve the customer problem, you might need to create some sort of a desktop application, some sort of a web application, some sort of a mobile application, some sort of a utilities, and then that everything combined together, that suite of projects that is combined together is your solution for that customer. And then exactly same idea is kept into the Visual Studio, where you have a concept called a solution. The solution is the set of group of related project. Right now, I have created a solution with a single project, that is nothing but the Hello World console-based application project. But as we will go ahead, we can create the multiple projects into the same solution, which will be, of course, related to each other. Now, when you come to the project, inside the project, you can write the code into one or more source code files. Your each project can have a separate configuration, right? Which is stored in a app.config. As time comes, we will discuss about that separately. And when we have created this, you can go and check what is happening in background. In background, for that solution, there is a folder created by the name Hello World. And in that Hello World, there is a file called as a SLNX file, solution file. This solution file is a kind of XML file which contains information about multiple projects in that solution. Currently, we have only one, and that is nothing but Hello World project. This Hello World project is having a main file called as a CSPROJ, talking about the C# project, and it is another XML file keeping the whole metadata about your C# project, where you can see the things about the C# configuration, project configuration, talking about the different warning levels and the compiler settings. It also have the option regarding the references that you want to include in your project. And most importantly, it contains your source code file or configuration files, right? That is good. Now, this is where the program.cs, this is the Hello World code that we have written. I have not yet explained to you, but yes, eventually I will talk about what is namespace, what is internal class, and everything. We will discuss about that one by one. And once this project is created, after that we said build project or build solution. What it created behind the scene, it created a bin folder, and inside bin folder, so you find that there is a debug folder. Inside debug folder, there is a helloworld.exe. This helloworld.exe is something that gets executed when I press Ctrl F5. But if you're a curious student, you might be interested in knowing how exactly this helloworld.exe was created when I did build. Well, if you want to understand this, then you cannot limit yourself only for this Visual Studio. What I'll do is that instead of limiting to this, I will take you to something called as Developer Studio. And this Developer Studio is automatically installed when we installed this Visual Studio. This developer PowerShell, or you call it developer command prompt. Now let me go to the D colon our folder. Right now there is nothing much over there apart from our hello world. What I'm thinking is that I will create a new C# file from scratch without using any ID. You can use any simple text editor like VS Code or Notepad++ or any other editor. I am planning to use a basic minimal notepad. So let me just use a notepad, and I want to create a file hello.cs. Wow, the file is created. As the file is created, I just want to write something called as a using system, where we are importing a system namespace, and then we have a class hello. Now inside this class hello, I want to write a public static void main, and it is string args command line arguments array, and inside this just now we have written console class static method write line, and I will just print again the same classic message hello world, right? It's wonderful. Now this .cs file is created. This .cs file is created by me. Let me compile this. How do I compile it? I can use C# compiler called as CSC, and I just write it hello.cs. Now you will see that it has created that hello.exe over here. It is the same exe that some time back you have seen into the bin debug folder, and you can run this hello.exe right here. Wow, you get exactly same output. So I was just trying to give you the idea what exactly happened when you create a project in Visual Studio. When you build it, when you run it, the behind the scene, you are using that editor for typing a C# file. And when you build it internally, the C# compiler come into picture, which is creating the .exe. And when you press Ctrl F5, you are actually running this hello.exe. I hope this given you the idea regarding what is happening behind the scene. Now, I really want to explain you what exactly it means and what exactly it is doing. It is not like very brief, that quick demo that we have shown. Now, if you really want to understand how exactly this .NET technology works, I would prefer to compare it with the other known technologies like C++ and Java. If you already know about C++ and Java, I believe you can learn better in comparison. Even though you do not know C++ and Java, I believe that looking at this quick understanding, this will give you more clarity about overall compilation and execution process in all these languages. So let me get started right from C or C++ compilation and execution. So typically, when we write a code in C language or in C++ language, so we write the files as .c or .cpp files. Now this .c and .cpp file, we usually give it to the compiler. The compiler create the object code, and then that object code along with the libraries are given to the linker, and then linker create executable file, right? Now this executable file, you can double click or you can run it from the terminal, and then it get executed on the operating system. By the way, what this executable file contains? This executable file contains the native code, or you can say machine level binary instructions, which are very well understandable by your CPU. So your operating system is passing these instructions to your central processing unit, your machine processor, and your program get executed one by one. This is a very basic, very primitive level understanding you can have. Now, if I want to compare this with Java, how exactly the Java compilation and execution is done. Now you will realize that Java compilation execution is little different as compared to your C++. And this is closer to how even your .NET works. So let me just tell you, when I'm writing a .java files, the Java source code is written over here. It will be passed to the Java compiler. The typically name of Java compiler is Javac. It will create a .class file, and that .class file doesn't contain the CPU understandable stuff, but it contains one intermediate language called as a bytecode. Now let me tell you that when Java technology started, one of the prime goal of the Java technology was a write and compile a program once, and that compiled program should be able to execute on any platform, on any operating systems. And that is the reason these Java compiler are not generating something which is OS or CPU understandable directly. Rather, they are generating a bytecode. Now, this bytecode will be then understood by a very special piece of software called as a JVM, developed by Java people. It is Java Virtual Machine. The JVM is available for Windows operating system, available for Unix operating system, available for Linux operating system, available for Mac operating system. So on each platform, this JVM is available, and this JVM is prime entity which converts your intermediate language code into the native code, into the machine level binary code, which can be very well understood by the CPU. Now, a lot of people have misconception that JVM is only for Java. Though you can say that yes, originally JVM was developed for Java. However, it is not limited to Java, because eventually people develop the other programming languages, and those other programming languages like Kotlin, Scala, these languages also support execution on the JVM. So you can write a Kotlin file which is given to a Kotlin compiler, and that will also create a bytecode which can be executed on the same JVM, because it will convert it to the native code and it will run on a CPU. And a similar story goes for the Scala and even few more languages. So the JVM, Java Virtual Machine, is not limited to one language, not limited to one platform. Well, now you see that somewhat similar philosophy was also thought by the Microsoft. Of course, Microsoft initiated all this .NET platform and everything basically for the Windows operating system. But they were very clear that we do not want that people should learn programming languages, multiple programming languages, to work on the .NET platform. So they respected that people might be coming from the C++ background, few might be coming from the Visual Basic background, few might be coming from the Java background, few might be coming from some other background. And for all those background people, they want that they should quickly adopt the .NET platform and should get started to work on the .NET. And that is the reason that they initially thought and supported many languages to be programmed on the .NET platform. Officially, 35 plus languages are supported on the .NET platform. Means you can write the program for 35 plus different programming languages. And this is official list. There is also the community supported languages available. The community supported more than 82 languages support is available for the .NET. So you may develop the application, .NET application, in any of the well-known language, and you will see exactly same output. Isn't it wonderful? So how exactly these people are working? So let me tell you that let your program be of any .NET language. Now, for that .NET language, there will be compiler, and that compiler will compile it into something called as intermediate language. Initially, this was referred as MSIL, Microsoft Intermediate Language. This could be a .exe file, this could be a .dll file, but it will contain an intermediate language. And again, like Java, this is not understandable by the operating system or CPU directly, but it is understood by a very special piece of software called as a CLR. CLR stands for Common Language Runtime. And this Common Language Runtime is one who will primarily convert your IL code into the native machine level binary instructions, which are then given to the CPU, and then CPU will execute it. So this story is applicable for now 82 plus languages. As you see that the language supported is C#, which is most popular language. And then there's a support for the VB.NET language, which is one of the favorite language by Microsoft. There's a language called F#, which is probably for the functional language. Earlier, they had support for the Java-like language called as a J# language, which is deprecated now, so it is outdated. And then there are also other popular languages which are eventually supported, is like Python, Delphi, manage C++, and then so many languages supported. So how exactly my C# code was executed? Just now you've seen that we written a code in C# in .cs file, given to the compiler. I shown you CSC compiler, and then that is converted into the intermediate language. And this intermediate language code is then given to the CLR, Common Language Runtime, which primarily convert it into the machine level code, which is running on the CPU. Maybe you are writing a code into the other language like VB.NET language, and then the flow will be similar. That compiler convert into the IL. IL is converted into the native code by the CLR, and then that native code is executed by the CPU. So any .NET language, the execution, the compilation and execution flow will be exactly like this. Okay. Now that you understood how exactly our Visual Studio worked, or how exactly this C# compilation, I could do it without Visual Studio, I believe now you should be interested in knowing that how do I get CLR on my machine? How exactly the CLR is to be installed on my machine? Now let me tell you, this CLR is part of something called as a .NET framework. So you never download CLR from the Microsoft website. So you can go to the Microsoft website and you can download .NET framework. In fact, some version of .NET framework is built into the Windows operating system. But then this .NET framework, what exactly it contains? It contains the main your execution virtual machine, that is nothing but CLR, Common Language Runtime. And then we have base class library, we have framework class library, and on the top of it, you can write the application using different programming languages. Well, that is nothing but the .NET framework. So let me just quickly talk about what exactly these things are. So first of all, as I said that Common Language Runtime, this is the main engine where your .NET applications will execute. This CLR is following the languages or the development following certain basic set of rules called as the CLS, Common Language Specification, CTS, Common Type System. The actual conversion from IL code to the native code is done by the JIT, just-in-time compiler. We have the memory manager, which manages the memory for your application, and its prime component is garbage collector, which will ensure that any unused objects are automatically deleted from the memory. So this is my main CLR engine. But only having that CLR engine is not enough to run the .NET application, because for .NET application to work, you need certain data types. You need some basic built-in classes, like maybe exception handling classes or file IO related classes, or maybe collection related classes. So all these classes, the certain libraries, the basic minimal libraries, they are part of a base class library. And this base class library is available in one file called as the mscorlib.dll. A kind of full form is Microsoft Component Object Runtime Library. DLL is of course a dynamic link library. And then this provides you very basic built-in classes like string class that we discuss into that HelloWorld application. But this may not be sufficient for developing a range of applications supported on .NET platform. Now, for that range of applications, you need some Windows application to develop. You need some web applications to develop. You need database connectivity to be done. You need something presentation foundation. You need communication foundation. And there are so many different things. Now, to provide all these features and functionalities into your .NET applications, you need the classes, and that is called as a framework class library. In fact, this framework class library means all these classes, all these reusable built-in classes that are available with .NET Framework. So when .NET Framework is installed on your machine, all these classes are installed on your system, and you can even consider this BCL itself as a subset of your FCL, Framework Class Library. And then, yes, you can develop the application using any of your supported favorite language. Now, to run the application on your machine or maybe your customer's machine, all that you need is only one thing, that is about .NET Framework. So that need to be installed on your client machine. And the primary components are CLR, base class library, and framework class library. However, .NET Framework is not enough for developing the application on your machine. So what you need extra? What you need extra is basically the C# compiler, VB.NET compiler. You need the debugger. You need some other tools. And all those things is part of my .NET Framework SDK. SDK stands for Software Development Kit, which includes your .NET Framework plus development tools like your language compilers, debugger. We have tools like ILDASM. We have like a code access security policy tool, and etc. Many such tools, they are available with the .NET Framework SDK. Well, then you ask the question, is it enough to be installed as a developer machine setup? My answer is yes. You can develop the whole range of .NET application just by having a .NET Framework SDK on your machine. However, for that, you need some editor separately, and then you need to go to the developer command prompt, and on that command prompt, you need to compile on command line, and then you need to execute your application, which seems to be a bit tedious job. Now, to increase your productivity, the Microsoft says that, okay, you need not to install .NET Framework SDK separately. All you need is only one tool, that is nothing but Visual Studio. Currently, we are using 2026 edition. When you install Visual Studio 2026, you'll find that it will have .NET Framework. It will have .NET Framework SDK. Plus, it is also installing that beautiful integrated development environment as a rapid application development tool. So you can quickly write the program, say Control F5, you can run that, and that should be absolutely okay, right? So I'm talking about the Visual Studio 2026 is the only thing that you need to install in your machine. And if it is installed, remaining all small components, they get installed behind the scene. This Visual Studio 2026 comes with 3 different editions. Number 1 is a community edition, which we installed right now because it is available for the students open source software developers, correct? Hobby programmers can use that. However, if you are going for the small IT company with a small team, and professionally, if you want to use that, then suggested is that you should be having professional version. The professional version, yes, of course, it is having the same set of features, but it is a paid edition and it is per seat license. So depending on how many machines that you are going to use Visual Studio, you need to purchase the license from the Microsoft. And if you are into the kind of very big company, like a multinational team or something like that, at that time, you should be purchasing enterprise license. Enterprise license is technically a bulk license where you can install on the multiple machines, correct? For our course, our training, the community edition should be more than enough. Community edition should be more than sufficient. By the way, if you go for the other platforms like Linux or Mac, unfortunately, this Visual Studio 2026 is not available. Now, over there, you have to use, first of all, not .NET Framework, maybe the newer edition of the .NET Framework, that is .NET Core. We will discuss about .NET Core sometime later. But yes, you can have .NET Core installed on your machine, on Linux machine or Mac machine. And you may use like Visual Studio Code with some extension, or you may explore some other IDEs available like IntelliJ or something like that, where you can do the development. Otherwise, you can always go for a command line compilation and execution, as I shown you some time back, right? I hope this should have given you a kind of a big picture about what is .NET Framework. Now, if you are bit knowing about Java, I would just do a quick comparison. The Java has got something similar concept. As you know that the Java, we have something called a JVM in place of CLR. We have something called as a JRE, Java Runtime Environment, in place of .NET Framework. And then we have something called a JDK, Java Development Kit, in place of .NET Framework SDK. But otherwise, things are similar over Java world as well. Anyway, now that you have understood the .NET Framework and we have seen the HelloWorld application, I believe now it is good time we can go one step ahead and we can look into the components inside the CLR, right? So let me talk about the components in the CLR one by one. The first, we will talk about the CLR and CTS. Let me begin with something called as a CLS, Common Language Specification. Now, I told you that the general compilation flow is nothing but any .NET compliant language, you will pass it, the source code, to the language compiler, and then it will generate the IL code. Now, this IL code is .exe or .dll. Broadly, you will call it as an assembly. Great. Now, as I told you earlier, the Microsoft, right from its inception, had a vision that we will not limit people to learning one or two languages only. The Microsoft always thought that the people from the different platforms can come to the .NET, different background can come to the .NET. So someone might be good into the Visual Basic, someone might be good into the C++, someone might be good into the Java, someone might be probably starting afresh in .NET itself. So at that time, the Microsoft was wishing that if people come from the different background, they should not be wasting their time to learn a new language syntax, but they should start developing the .NET platform for the .NET platform as early as they can. And that is the reason they thought of supporting many different languages. And then they also had a vision that to work on a single project, that there can be the part of a team might be expert into the C++, the part of team might be expert into the VB.NET, or some other team can be expert into some other languages. So problem is how these people will be able to work together on a single project. So the primary vision that they had all the time is nothing but language compatibility or language interoperability. For your big solution development, you might create your business logic into a C# project class library. So you can create a class library which will have the set of classes which are created as a dynamic link library. It is a reusable set of classes. Of course, the developers who are good into the C#, they can work into this project. But then there might be some other team, and the experts over there, they are the Visual Basic expert. Visual Basic is traditionally the language where people prefer to do the drag and drop and quickly develop some really awesome GUIs. So my another team, which is coming from the Visual Basic background, so they want to develop a desktop application. So they might choose something called as VB.NET as their programming language. And they want to create one executable file which you can run by Control F5 or double clicking that. But for these people, they need not to write the core business logic again and again. All they can do is the library, the set of classes which were reusable classes, which were written by the first team, they can directly import in their VB.NET application, and they can start using it in their project. Not necessarily it is about the VB.NET only. There might be some web-based application, web-based solution that you want to create. Now for that web-based solution also, what is possible that this same C# created classes in DLL can be imported for that web application written into altogether a different language, and in that particular project, these classes can also be referred and reused over there. Then you ask the question, is it possible directly? No, Microsoft wanted this to happen. And in order to ensure that this is going smoothly, they defined certain set of rules and regulations, and those set of rules is nothing but what we call it as a common language specification. Now, let me tell you that these are the rules to be followed by the languages. These are the rules to be followed by the developers. Primarily, these rules are for those people who are trying to write the new languages or people who are trying to write the language compilers. So anyone who is making a .NET compliant language, he has to write a .NET language compiler. And that compiler, while writing the compiler, he should keep in mind that certain rules must be followed so that a consistent MSIL code or IL code is generated into one project, and then that IL code is referred from another project, which is of course again going to be compiled into the IL only. So actual compatibility is not going to happen onto the language level. The actual compatibility is going to happen on the IL level. And to make it happen, so compiler designers has to follow the rules and regulation that what kind of IL I want to generate. Of course, it is now the big documentation, so many different rules. I'll just give you a little trailer. There are a couple of rules I have mentioned over here. The first rule, the object must be allocated using new operator. So irrespective of you are working in C# or J# or VB.NET or F# or C++, any of the .NET supported language, when time comes to create any new object, it has to be created using new operator. So new class name and the object is to be created. Rule number 1. Another rule is, let's say only signed type is allowed. You might have heard of the data types like int and unsigned int, short and unsigned short, long and unsigned long. So in a normal int version, we can have positive value, negative value, and unsigned version, we can have only positive value. We do not have the negative value. Now you ask the question, does CLR support the unsigned data type? Answer is yes. CLR support unsigned data type. However, not all programming languages have support for unsigned type. There are certain languages which like to restrict to only the signed type. So if you really want to make some code in one language to be accessible by other language, you have to come to the lowest common denominator. So the data types which are supported by all the languages, and those one are nothing but signed type. It doesn't mean that CLR is not supporting that, but though CLR is supporting that, it may not be usable into the other languages. Like, for example, you consider a class program where I have written one method called a square. And this square method has got integer argument, which is signed argument, correct? Now this signed argument, if I created this method, this method is very much compliant to common language specification, right? But I may write also another method which is using unsigned integer, and that makes your function, your method as not compliant to the CLS, common language specification. So what is significance of this? The significance is, if this code written in the C# library, then this code is accessible from all other .NET compatible languages. However, this may not be accessible from other .NET compatible languages, especially the languages which are not supporting the unsigned data types. I hope I made my point clear that CLS rule says that only signed types. And as usual with the C++, Java, and many of the other languages, we are looking for stack-based execution, meaning by any time any function is called, a kind of stack frame or function activation record will be created. The local variables will be created on the stack. And when the function is completed, those local variables from that stack frame function activation record, they get destroyed. So this is the overall idea what exactly the CLS is. So there are many such further rules, but these are the few one to give you idea what exactly you mean by the common language specification. And I guess now it's time that I should talk about the CTS also. The CTS, you can consider it as kind of an even broader term. CTS is common type system. The common type systems talk about the data types which are present in your intermediate language. The data types which can be very well understood by the Common Language Runtime, the main execution engine. And then these CTS types are primarily divided into the two parts. One part is said as value types. Another one is reference type. What is the idea? Value type and reference type. In a very simple language, the value type is one whose variable represent a value, whose variable stores the value. That is called a value type. What exactly it means? What exactly it means that it is int32 is a value type. A is a variable of that type. I am assigning a value, let's say 123. What exactly will happen when a variable is created in memory? When that a variable is created in memory, that a variable will actually store 123 as a value. And that's why it is called as a value type. It is called as a value type. If it is a local variable inside a function, then this value type will be created on the stack. I repeat my point. When a local variable of the value type is created, then it will be created on the stack. If you at all create this variable as a part of some class, as a data member or something like that, then it is not created on stack. At that time, it will be present into the heap. However, for the local variable, yes, it will be on stack. Now, there are many data types into the CTS, where you talk about the int16, which is 16-bit integer, int32, 32-bit integer, int64, 64-bit integer. We also have byte, which is 8-bit integer. We have single, like a float value of 4 bytes, double, Again, a floating point value of 8 byte. Here single talks about single precision, double talk about the double precision. And if you're looking for maybe more exact precision, then you should look for the decimal type, which needs even higher storage. You may also use the Boolean with the values true or false. You can represent a single character, and there are even unsigned counterpart of few of these types, like you have the UINT16, UINT32, and so on and so forth. But apart from these built-in types, there are also the user-defined types. And the primarily user-defined value types that we have are nothing but the structure and enum. If you ever come from a background of C and C++, you might have heard of structure and enum, which is quite similar to this. As we will progress further, we will have a demonstration of structure, enum, class altogether. But these are the value type. Again, remember the basic idea. The basic idea is whenever you declare a variable integer a is equal to 123 in C#, what will happen? When the code is converted into MSIL, that MSIL conversion will not keep it INT, it will convert it into the INT32 type, which is the INT32 type, which is basically a CTS type, which is understandable by the CLR type. And when it is created, the variable will store the value. Variable will store the value, not the address. Now, I am telling you this because if you understood this, understanding a reference type should become very simple. So what is the reference type? The reference type is primarily representing a reference, or you can say address, or you can say like a pointer it represents. And then there are different reference types. Hardly 4 or 5 are there. Number 1 is a class. Each and every class that you see, it is a reference type. In that HelloWorld application, we have seen string. In that HelloWorld application, we have seen that console. These are the classes. And that every class is the reference type. Then we have interface, we have array, we have delegate, something new feature of C#, and we have the object class. So you will find that all these types, these are the reference type. Why they are called a reference type? Because if you create a probably string like this, so string s is equal to DAC, what will happen? What will happen? That s will get created, and that s is not storing DAC. In fact, the DAC is stored as a string object somewhere on the heap, somewhere in the heap or into the string pool. It will have certain address, and that s variable will actually store that address. That s variable will actually store that reference. It will not store the DAC value. And that is the reason it is called as a reference type. It is not called as a value type. So all the class object, in future, we write the kind of class employee, class student, class person. So you will find that it will have the similar structure. So when I'm writing person P is equal to new person, the P is not storing the person data. That person P is going to store the object's address, object's reference. The actual object will be created on the heap, and the data will be stored over there. So if I just take you back to that .NET diagram. In the .NET diagram, I shown you about the CLR. And inside CLR, I was talking about the specification like CLS, like CTS and all that. Now, why not to take a look at the most important part called a JIT. Let us take a look at the JIT. JIT is just-in-time compiler. As I said that CLR is converting from your IL code to the native code. The primary component in that CLR is nothing but the JIT, who is doing the job, who is converting your IL code into the native code. Now the question is, how exactly this conversion is done? Typically, this JIT we call it as a compiler, not as an interpreter, which is usually the Java people call it as a JIT interpreter. Here we are calling it a JIT as a compiler because it is not going instruction by instruction, but it is doing that conversion method by method. So whatever is the next method to be executed, in advance, it will convert the whole method IL code into the native code and then let CPU execute that. Now, typically, you will find that certain methods which are getting called again and again. Like, for example, if you're going with the console application, maybe console.writeLine is kind of a method that you are calling many times in your application. If the same method is getting called multiple times, each time method is called, if the conversion is going to happen from the IL code to the machine code, it will take a long time. So your JIT compiler is showing some smartness. What it is doing is these frequently called methods converted to native code, it will cache it so that if the same method is called next time, it will directly use cached native code. It will not reconvert it again into that native code. That is wonderful. And then this JIT has got some types. One JIT is, you call it a standard JIT. The standard JIT, that is something that we are currently using on our system. It is very much part of the CLR and it is available on all the devices. If you have ever come across a bit Windows phones, those Windows phones had one small footprint of the .NET framework called as a .NET Compact Edition. Now, those were the devices which were running on the low memory. Now, for them, this standard JIT was not very suitable. And that is the reason they come up with something called Econo JIT or Economy JIT, so that they can perform better onto the devices with the less memory. Now, you can find that maybe these .NET Windows phones are not seen anywhere. So this Econo JIT is also deprecated, it is also outdated. And then we have third one. The third one that we have is a Pre-JIT. Now people do compare the performance of C# with maybe C++ and the other languages. Typically, when you come for the C++ code, the biggest advantage that you get is your code is already the machine level code. And that machine level code is directly given to the CPU. That makes your C++ applications the far fast as compared to the other Java or .NET based application. Now, of course, the .NET people thought of this and how we can improve on that. Is there any possibility that we can convert my .exe whole IL code directly into the native code before the execution? And that idea was implemented as a Pre-JIT, which is also referred as ahead of time conversion, ahead of time compilation. So all your IL based code will be given to the Pre-JIT. This Pre-JIT is typically known as something called as an engine.exe, or full form is a native generator.exe, which can convert all your IL code into the native code before your execution, so that the code that now you have is not the IL code anymore. The code that you have is the machine level code suitable for the machine on which you are going to run that application. And that is the reason when the application starts, it will run quite faster. It doesn't really need JIT for converting your code at runtime. It is already converted. And then people have question, does it really mean that it is also escaping the CLR from that? No, I'm not saying that it is escaping the CLR from that. I just say that the JIT part is skipped. The conversion from the IL code to native code is skipped. But it doesn't mean that CLR is not there. Yes, CLR is still loaded at runtime because CLR is not only JIT. CLR is also about the memory management. CLR is also about CLS and CTS. CLR is also about the garbage collection, security policy, and many more things. So though the conversion is done natively, the CLR component is still loaded, and the CLR, garbage collector, security policy, and other execution engine components, they will be helpful for executing the application, but the conversion of your code will be kind of saved at runtime. Isn't it a fantastic feature? Now, let us go ahead and talk about the other one or two remaining concepts. The other one or two remaining concepts is primarily talking about the memory management. The CLR is responsible for the memory management of your application. So the memory required for the class loading, or we talk about like a stack, the function at which records are created on the stack, and the function is called. Just now I talk about the caching, that any code which is used frequently, the native code has to be cached. So all that memory that you need, that will be managed by the CLR behind the scene. That is good. And what if my application want to create the new objects like new person, new employee, new student kind of stuff? So all those objects will be allocated using new operator as a part of CLS, correct? But you never delete them manually. There is no feature that you can explicitly delete any object. Rather, all these objects are automatically deallocated when they are no more referenced. If not a single reference pointing to that, then the garbage collector come into the picture, and that garbage collector will release all these objects, will do the cleanup of all these objects. Typically, it uses something called the mark and sweep or mark and compact algorithm. We will talk about the garbage collector sometime later when we will discuss about the resource management stuff. And then the execution engine, that runtime execution engine, the CLR is having, yes, of course, it is having the garbage collector. It is also having the security manager. And yes, it also have few more components. This was a very high level view of what .NET framework is, what CLR is, and what are the prime components of the CLR, right? I guess with the HelloWorld application and these foundations ready, now we can go ahead with bit more complex applications where we can understand that how to create the DLLs, how to refer the DLLs, correct? And how these particular programs are actually executed. But we will talk about all these .NET assemblies, their compilation and execution in our next session. So thank you very much.